So in this video, we're going to look at confidence intervals for matched pairs data. So a 1 minus alpha times 100% confidence interval for mu sub d is given by the lower bound is going to equal d bar minus t sub alpha over 2 times s sub d over the square root of n, and the upper bound is going to be d bar plus t sub alpha over 2 times s sub d over the square root of n. The critical value t sub alpha over 2 is determined using n minus 1 degrees of freedom. The values d bar and s sub d are the mean and standard deviation of the differenced data. Note the interval is exact when the population is normally distributed and approximately correct for non-normal populations provided that n is large. And so n is large meaning 30 or more. So what we have here, this t sub alpha over 2 times s sub d over the square root of n, that's our margin of error. So what we're going to do is we're going to find the differences between each pair of data, and we're going to find the mean of those. That's d bar. So that is the mean of the differences between the two data values. S sub d is the standard deviation of those differences. And so this formula is the same formula really that we used when we were finding a confidence interval for a population mean. The only difference is we're finding the mean of the differences of the paired data and then using this as the margin of error. But it's basically the exact same thing we did when we were finding a confidence interval for a population mean. So let's take a look at an example. Braking distance. An automotive researcher wanted to estimate the difference in distance required to come to a complete stop while traveling 40 miles per hour on wet versus dry pavement. Because car type plays a role, the researcher used 8 different cars with the same driver and tires. The braking distance in feet on both wet and dry pavement is shown in the table below. Construct a 95% confidence interval for the mean difference in braking distance on wet versus dry pavement, where the differences are computed as wet minus dry. Interpret the interval. Note, a normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. So we want to construct a 95% confidence interval for the mean difference between the braking distances of wet versus dry pavement. So we need to start by finding the differences between the wet and the dry pavement. So I'm going to use my calculator to do that. So I have already entered the data into list 1 and list 2 in my calculator. So in list 1 I have the wet braking distances, and in list 2 I have the dry braking distances. So if I go to list 3 and highlight L3, and if I take list 1 or L1 minus list 2, so I get L1 from the second of my 1 button, L2 from the second of my 2 button, and when I hit enter, the calculator computes all of the differences, wet minus dry. So for the first car, on wet pavement, it took 106.9 feet to come to a complete stop. On dry pavement, it took that car 71.8 feet to come to a complete stop. So that was a difference of 35.1 feet. So let's write that down. So this was a difference of 35.1 feet. Now for the second car, it was a difference of 32.1 feet. For the third car, it was a difference of 34.7 feet. And for the fourth car, it was a difference of 38.4 feet. For the fifth car, a difference of 29.1 feet. For the sixth car, 30.4 feet. For the seventh car, 34.9 feet. And for the eighth car, 26.9 feet. So these were the braking differences. In each case, it took a longer distance to stop when the pavement was wet than when it was dry. And so again, we're looking for a 95% confidence interval for the mean difference in braking distances on wet versus dry pavement. So to do this, we need to begin by finding the mean difference and the standard deviation of these differences. And incidentally, it is these differences that we found a normal probability plot and a box plot for here. That's what's mentioned here. So if we did a normal probability plot of these 8 differences, that indicates that we have a normal probability distribution. And if we do a box plot, there are no outliers. So that's what this note was about. It was on those 8 differences. So we need to find the mean and the standard deviation of these differences. Since we have those differences in list 3 on the calculator, I'm going to use that to find d bar and s sub d. So go back to the home screen. I'm going to go to Stat and Calc, one variable statistics, and I want to do that for the data in list 3. So if I calculate, now the calculator calls it x bar, but that's really d bar, is 32.7. So the mean for our sample was 32.7 feet. That again is the mean difference between the stopping distance for wet versus dry pavement. The standard deviation, S sub d, again is denoted S sub x on the calculator, but that is 3.767151254. So S sub d 3.767151254. So that is our standard deviation. Now, to find our 95% confidence interval, we're going to take d bar minus the margin of error to d bar plus the margin of error. That will be our 95% confidence interval. But we need to figure out what that margin of error is if we're doing a 95% confidence interval. We do know d bar already. We need to calculate the margin of error. Well, to calculate the margin of error, our formula is t sub alpha over 2 times s sub d divided by the square root of n. And again, that's really the same formula that we used whenever we were doing a confidence interval for a population mean. It's just that we're dealing with the differences instead of specific data. So we got to figure out what that t sub alpha over 2 is going to be. So let's do that here. Now in this case, we're dealing with a t distribution. And our t distribution has 7 degrees of freedom because our sample size is 8. We have 8 pairs of data, so n is 8, which means the degrees of freedom is equal to 7. We're doing a 95% confidence interval, which means this area here in the middle is 0.95, which means the 2 tails contain the other 0.05. Half of that in each tail. So 0.05 divided by 2 is 0.025, and so the area in each tail is 0.025. We need to figure out what these 2 critical values are. Well, how can we go about finding those 2 critical values? Well, we can use the student's t distribution table in order to figure out these values. We can use the inverse t command on our TI calculators if you have that on your calculator, or we can use the t calculator in StatCrunch. Any one of those will allow us to figure out these values. I'm going to use the inverse t command on my calculator. So if I go second distribution and inverse t, in this case the area in the far left tail is 0.025, and I have 7 degrees of freedom. So if I paste that, here's my command, and so I get a critical value of approximately negative 2.365 if we round to 3 places. So that is this value here. Negative 2.365 is this value, which means this value is positive 2.365. So our critical value is 2.365. So our margin of error is going to be 2.365 times the standard deviation of the differences, which is 3.767151254. So 3.767151254 divided by the square root of the sample size, and the sample size is 8. So if I punch that in my calculator, 2.365 times 3.767151254 divided by the square root of 8, that is approximately 3.15 if I round to two places. So this is approximately 3.15. So for my 95% confidence interval, I'm going to take my D bar 32.7 and subtract 3.15, and I'm going to take the 32.7 and add the 3.15. Well, 32.7 minus 3.15 is 29.55. So this is 29.55. And if I take 32.7 plus 3.15, that is 35.85. 35.85. So what does this mean? Well, I'm 95% confident that the true mean difference between the stopping distance on wet pavement versus dry pavement is somewhere between 29.55 feet and 35.85 feet. I'm 95% confident that the true mean difference is in there. Now this is our by hand computation. We did use the calculator to calculate D bar and S sub D, and we did use the calculator to come up with our critical value. But we could also use the calculator to directly find this confidence interval. So I want to show you that next. So if I bring in my calculator, go back to Stat and Edit, we calculated the differences in list 3. Well, once I know the differences in list 3, I could use that to directly find a t-interval, and that t-interval will be the confidence interval that I'm looking for. So if I find a t-interval for this data that I have in list 3 now, the differences, that t-interval will be the confidence interval that I was looking for in this problem. So again, I have the differences in list 3. I'm going back to the home screen. So if I go to Stat and Tests, and if I do a t-interval, which is option 8 on my calculator. Now in this particular case, we have data, so I'm going to highlight data, and that data is in list 3. So I'm going to tell the calculator that the data is in list 3. And I have a 95% confidence interval that I'm looking for, so C level's 0.95. So if I calculate, then I get 29.551 to 35.849. So if I round, that's 29.55 to 35.85, which agrees with the computations we got by hand. Now I could have also done that by going to Stat and Tests and doing a t-interval. And instead of data, if I have statistics, which I do have, I know X bar is 32.7. Now that's really D bar. And I know the standard deviation's 3.76715, blah, blah, blah. Again, and the sample size was 8. We're doing a 95% confidence interval. So instead of using the data in list 3, I already knew my mean and standard deviation if I've calculated those, and so I could use that to do the confidence interval as well. Now, we could also do this in StatCrunch. So here in StatCrunch, I have already entered the braking distance for the wet pavement and the braking distance for the dry pavement in these first two columns. So if I want to calculate a confidence interval for the mean difference, I can go to Stat and T-Stats, and in this case we have paired data. This is the same place where we went in the previous video to do the hypothesis test. So I select paired. Sample 1 is the wet pavement. Sample 2 is for the dry pavement. And so in this case, instead of doing a hypothesis test, I want to do a confidence interval. And I do want a 95% confidence interval. So enter the level of confidence if you need to. In this case, it's there already. So if I say compute, StatCrunch gives me the lower limit, which is 29.55. That agrees with the result we got both by hand and with the TI calculator. The upper limit is 35.85 if I round to two places, which again agrees with both our by hand computation and the calculator computation. So again, we are 95% confident that the true mean difference between the braking distance for wet pavement and the braking distance for dry pavement is somewhere between 29.55 and 35.85 feet.